Building 3 is our machine shop and light manufacturing. This is the next stop on our tour. The guys call this our teardown room. They take rear wheel bearing units apart. Kurt has a desk where he does the turbos. And it's also our nail strip room. We got John over here. In a second he'll tell us about nail strips. John, what do you normally do during a week?
I may be building starters, generators, power glide transmissions. I'm on the phone quite a bit answering technical questions, unloading trucks. Quite a variety goes on around here, and if I'm unlucky I end up with nail strips.
Oh, the fabulous nail strips. Yeah, tell us a little bit about nail strips.
Sure, the first thing we do is we have a sample and we'll cut it to length with our marking jig, which is a sample piece that matches up to what we want to make. At that point what I would do is put it to my cut piece and mark each of my slots where I want to put a notch in. Then I would take our notching pliers here and I'm going to actually cut a notch in it. And I would do that all the way down the nail strip as this finished one is here.
Okay, what's that notch look like?
That notch is just a nice V, and that allows us to make nice bends in the nail strips.
Okay.
So then this is what we'd end up with for a finished piece, and there's quite a bit of handwork involved here in notching this all the way down. Once this is done, I would take this piece over here to our bending jig. At this point what we would use is pretty much, again, it's all handwork. It's going to be done with a hammer and kind of a dolly and a bending jig, and we're going to follow this nail strip all the way around this stainless steel jig till we get our proper shape. Once we have that, again, it's still a lot of handwork. We're going to go back with pliers. We're going to smooth it all out because the back side of the nail strip is what shows to the upholstery side. And the smoother we get that, the better finished product we end up with.
What are all these little pointed notches for, John?
Well, this is what the vinyl is going to get wrapped around, and then these get bent down to hold the vinyl tight to the door panel, Cal. So once we have them all bent and smoothed out the way we want, we take it off of the jig and we bring it over here and we actually mark it. This jig here shows us exactly where we want to put each of our nails. We put these serrated nails in, and these will end up actually going into a plastic insert into the door itself.
How do you know where they go?
We're going to use this jig here, and it's got a little small hole in the end of it, and it marks so that I can put a magic marker mark in each place where I want a nail to go. At that point I take it off of our jig and bring it over here, and I'm going to weld it. This is a drawn arc welder. Works pretty slick. So I got a black dot right there, which is what I'm aiming for. Set the gun and the nail directly on it. Pull the trigger, and it welds it on there perfectly.
Okay, and you probably can't see it, but that nail has ribs on it, and that's what holds it into the plastic in the door panel.
This is a finished product of the nail strip that we just made. This is for a 60 to 64 front door piece, and it takes 4 pieces all together to make a complete front door.
Okay, thanks very much, John. Next we're going to visit with Kurt, who's worked for us for 26 years. Kurt, how many turbos and turbo carbs did you do this year?
Well, Cal, actually this year has been a record for us for turbochargers. 28 came through the doors this year, and carburetors roughly 30.
Wow, that's a good number for 1 year.
So it's been very busy, and customers send us anything from items that just need a little bit of a touch-up. Sometimes they send us just a box of pieces to be put back together again.
And what have you got on the table in front of you?
What we got here is a customer's carburetor that's just getting ready to head out the door. We're going to put it on the car later, drive it around and see how it works.
For those of you that don't know, Kurt puts both the turbos and the turbo carbs, and if you send both, he puts both on the car, and they are tested before they get sent back to you.
Yeah, so when the customer opens their box at home, they simply remove the unit and place it on the car, and it's ready to go.
Kurt's going to show us what the difference is between the 150 and the 180.
Yeah, Cal, many people call up and ask what the difference is, and it really comes down to diameters. This is 150 horse, which has a decent diameter to it. But as you can see, Chevrolet jumped up in the later years to a larger diameter.
Okay, and that's just this diameter here, right?
Correct.
The rest of it's the same?
Right, that is correct.
Okay.
It gives a larger surface area. And also to accommodate, don't forget, in 1964, they jumped up the cubic inch displacement of the engine.
And what is this beauty on the table?
Again, as I said before, sometimes customers send us disasters. And this was the result of someone trying to do it themselves and ended up out a whole lot of money.
We didn't have any actual sets of connecting rods to put on pistons today, but we did want to let you see this important step that we can do for you. This is a connecting rod oven, and the connecting rods actually go down into this oven. Small end first. Kurt closes up the door. Have to wait for it to warm up, and then it's taken over to the piston press.
All right, Cal, looks like we're ready. The wrist pin area is nice and purple. That tells us we're ready to go. Bring it over here. We're going to hang it right off the edge of that. We're going to slide our wrist pin in. And then we're in. And this sets the depth also, so that now when this cools and remove the connecting rod back to its center post, what's going to happen is we're going to have the correct amount on each side of the piston here of wrist pin hanging out. If somebody was to try to do it themselves, they may end up with the wrist pin all the way one direction or not enough in the other.
Okay, and I also noticed that you heated that piston ahead. Why was that?
What happens is, especially with the cast seem to be most susceptible to it, is the aluminum, when it's cold, is just a touch too small and you have to force the piston too much. So we warm them up just to relax them.
Okay, and the main reason that we're heating that connecting rod is what?
There's at least 1,000, sometimes up to 2,000 interference fit built into here. We have an 800 thousandths wrist pin, and so the wrist pin hole in the connecting rod is 1 to 1.5 thousandths smaller than that.
Okay, so if you don't heat it up and you force the wrist pin through the connecting rod, it's apt to score the wrist pin, which then gets scored and goes into the piston and can make the piston hard to rotate.
That's correct. This makes the process very clean. The heating process does not compromise the connecting rod in any way and allows for a nice, smooth transitional fit.
We're now in the rebuilding room in Building 3. It's part machine shop, part cleaning. We've got some old machinery that works great for us because we don't do big production runs. We mainly do small cleanup jobs or very small production runs that most shops don't want to be bothered with. Another thing that the guys rebuild in this building are the carburetors. And we generally do between 400 and 600 carburetors a year. We also do alternators, generators, and starters, and we're extremely proud of these. Especially this year, we are now using brand new rotors, brand new stators, and all the parts that we have been putting in the past. The main reason for going with a new stator is that these actually have thin insulation between the metal parts, and after 40 or 50 years we found that it's deteriorated. The same goes for the rotor. Some of the insulation there has deteriorated. The same is the case with the generators. We've just given up with the field coils, the old armatures. The insulation in this area deteriorates, and we now are including brand new armatures, brand new field coils, and everything else that you see on the table except for the end frames will be brand new in the generators. Right down to the tag held on with the original style rivets. With the starters, brand new armatures, brand new field coils, all the other parts brand new. You can even order them with a brand new nose cone. We completely go through these starters. I don't believe you can buy a better starter. They should be just as good as when they originally left the factory. Even with all the new parts that we put into the alternators, generators, and starters, when we're all done, we still load test each one. In this room we do our honing, boring. We recondition connecting rods with this machine. And a few years ago we bought the heated, agitated, ultrasonic cleaner. This thing has been one of the best machines we've ever bought. It just makes everything so beautifully clean. Carburetor parts, transmission parts, everything we put in it. The guys are just thrilled with this machine. A few years ago we came out with our brand new full fin cylinders. However, some people want to save some money, and for this we still do bore and hone the original cylinders.
Just so happens, Cal, I'm in the middle of boring some of the late model 20 overs. The boring bar gets centered. There's centering feet on the inside, locked into place. We retract the centering feet, engage the drive, start her up, and bore. After the boring process, we're now within a couple of thousandths of having a great cylinder. So turn the oil on, bring the stones down in, get a little bit of tension, and get started. When we get done, we'll have a cylinder that has about 1 to 1.5 thousandths of clearance built into it and a nice crosshatch pattern.
Well, thanks very much, Kurt.